Parabola. Let's look at the definition. So the locus of a point which moves in a plane such that its distance from a fixed point is equal to its distance from a fixed line. So which means you have a fixed line, you have a fixed point, and the locus is such that the distance, this one, is equal to this. This 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 is equal to this. So this is the curve that we are talking of, a parabola. Now let's look at it analytically. So let us say this is S and an arbitrary point P, and let's say this is M, the perpendicular from the curve on the point on the curve. So S is the focus, L is the directrix. That fixed line is called the directrix. Now let's draw a line SZ which is perpendicular to L. Okay, so let's do that. Let's have a fixed point, the directrix. Then let's draw a line which is perpendicular to, this is S, this is Z. Okay, now that we have this, let's find the midpoint of S and Z and treat it as the origin. So our coordinate system would be, this is X and this is Y. Now coordinates of S would be what? Let's say this distance between O and S is A, right? So which means this would be minus A, because this is equal to this. Origin would be the midpoint of SZ. So which means OZ is equal to OS is equal to, let's say, A. Coordinates of S would be what? This is going to be A comma 0, A comma 0. And the equation of L would be what? Equation of directrix would be X is equal to minus A, right? This is our directrix L. X equal to minus A means what? X plus A equal to 0. So that would be the equation of the directrix. Now let P be an arbitrary point on the curve. So let's say this is the point, arbitrary point P, whose coordinates is X and Y. Now we know, as per the definition, that SP by PM, the ratio which is represented by E, is 1 in case of parabola. Now here remember, SP is the distance from the focus to P, and PM is the perpendicular distance from P to directrix. So now which means we can write this as SP is equal to PM. That means these two lines have to be equal, right? The perpendicular distance and the distance between S and P. So let us say this is M. Now SP, if you think about it, is nothing but the distance between two coordinate points. So the distance would be square root of X minus A the whole square plus Y minus 0 the whole square is equal to magnitude of X plus A, the equation of the line, divided by 1 square plus 0 square is the equation of the perpendicular distance from a point to a line. Okay, now let's simplify this. So square it, X minus A square plus y square is equal to x plus a by 1. So we can just leave it as it is. Now let's open it up. X square minus 2ax plus a square plus y square is equal to x plus a. Oh, this would also be square. So this would be x square plus 2ax plus a square. Now x square gets cancelled, a square gets cancelled. So we are left with y square is equal to 2ax plus 2ax, and finally y square is equal to 4ax. This is the equation of the parabola. Now to get a simple equation of parabola, we chose a particular coordinate system, a particular point as the origin. We chose the x-axis, y-axis, so that we could get a simplified version of this equation. Okay, now let's look at some way by which we can figure out the shape of the curve or shape of the parabola. Now remember, y square is equal to 4ax. So if we substitute y replaced by minus y, what happens? Because of that y square, no change. So if x comma y lies on the parabola, implies that x comma minus y lies on the parabola. So therefore we can say that parabola is symmetric with respect to the x-axis. Now when x equal to 0, y equal to 0, so x-axis meets the parabola at 0, 0, or rather we should say the parabola meets the x-axis at 0, 0, and this is called the vertex. That meeting point is called the vertex. Axis, if a conic is symmetric with respect to a line, then it is called an axis of the conic. So here x-axis is the axis of the parabola. Similarly, vertex, the points where the axis of the conic meets the conic are called the vertex of the conic. Now because I am using plural, it means basically that there can be more than one vertex. Again, y square is equal to 4ax. If a is greater than 0, it implies that x is greater than or equal to 0. Since y square will always be greater than or equal to 0, because even if y is negative, its square would be positive. As x approaches infinity, y square would approach infinity, which means y would approach infinity in quadrant 1. When we say since y approaches infinity in quadrant 1, basically we can say that the curve is not closed, it is open. Now if a is less than 0, y square would be minus 4ax. Now y square should not be negative, then we get into imaginary worlds. So x has to be negative. So x would be less than or equal to 0. That means curve opens to the left. So here it would be something like this, and here it would be something like this. Okay, a line through the focus is called the focal chord. Okay, so there can be n number of lines going through the focus, but there will be only one line, the focal chord, perpendicular to the directrix. So only one line would be there which would be perpendicular to the directrix, and that is called the latus rectum. Now we know that if we go back here, the line going through S is x equal to a. So the line going through the focus is x equal to a. So the equation of the latus rectum is x equal to a. Now LR meets the parabola at 0, no, not 0, at a comma 2a and a comma minus 2a. So let's very quickly draw the line. Okay, so let us say this is the directrix and this is the focus and this is the line. This is the focal chord. The line from here to here is called the latus rectum, and this is the focus. This is the x-axis. This is going to be a comma 0, and let's say L. This would be a comma 2a, and let's say this is L prime, and this would be a comma minus 2a. Now L and L prime are called the end points of the latus rectum. Now the length of the portion of LR intercepted between the endpoints of LR is called the length of LR. So LSL prime would be equal to length of latus rectum. Now we know the coordinates, so we can find the distance between them. So square root of a minus a square plus minus 2a minus 2a square, which is equal to, now this becomes 0, this becomes minus 4a square. The square and the square root gets cancelled and we are left with minus 4a. And since we are talking of length which can't be negative, we have to take the absolute value of this. So equal to 4 times the absolute value of a. And finally, let's say px comma y is any point, an arbitrary point on the parabola. Y square is equal to 4ax. Now SP is the distance between S, that is at a comma 0, and P, that is x comma y. So that can be written as, since we know the coordinates, x minus a square plus y square. Y minus 0, so 0 we don't need to. Which means this and this square gets cancelled and we are left with x plus a. Again we are talking of distance, so which means it would be, so since we are talking about the distance, it has to be x plus a. We can't have a negative result. Okay, now let's take an example. Let's say the equation that is given to us is y square is equal to 8x. A very simple case. Now what we have to do is we have to convert it into 4ax form. So y square is equal to 4ax. So a would be what? A would be 4 times 2. So 2, right? So which implies that a is equal to 2. Now once we know that, let's see what all we can figure out. Focus is a comma 0. So that means focus is at 2 comma 0. Directrix is x equal to minus a. So x equal to minus 2 is the equation of the directrix. Or we can write it as x plus 2 equal to 0, equation of the directrix. Vertex we know is 0 comma 0. Axis is the x-axis. So y equal to 0. Length of LR, latus rectum, is 4 times magnitude of A, which is equal to 8. Now equation of latus rectum is x equal to magnitude of A. So x equal to 2. End points of latus rectum A comma plus or minus 2A. So which implies 2 comma plus or minus 4. And now it's just a question of plotting the graph. So that is parabola. I think that's enough. Bye for now.